Okay, we are going to try to do this. Chapter 1, Section 6, two-dimensional figures, take 2. Apparently I messed up the first time, so I'm doing this the second time. Alright, so you're going to identify and name polygons. You're going to find the perimeter, circumference, and area of polygons. Now, keep in mind that I'm not going to do any examples of the perimeter and area. I am just going to, I thought I had done something here. I am just going to, y'all should know these examples and how to do those. So I'm not going to worry about doing examples here. We'll worry about it in class. Now, a polygon is a closed figure formed by a finite number of coplanar segments called sides. In other words, if we have a bunch of sides put together and it stays closed, it's a polygon. But keep in mind, the sides with a common endpoint are non-collinear, and each side intersects exactly two other sides. That's important. Exactly two other sides, but only at the endpoints. So, back up. Okay, so here's a polygon. I'm not going to give it a specific name based on sides right now. I'll do that in a minute. But you can see here I've got some little angles or little vertexes and stuff like that. All these little endpoints that you see here that I'm coloring in red, those are called vertexes of a polygon. And you would say like it's vertex, say J, or vertex K, or vertex L. The sides are side, and then you put the 2 points that make up the side. Notice how I have the GH, side GH, with a line underneath. I could say side HJ, side JK, side KL, side LM, so on and so forth. Now, all polygons are named based on all the vertices of that polygon, and in order. Okay, so in this case, I could say that's polygon GHJKLM. Now, based on the way I read that, I could start off with J and say JKLMN, like that, JKLMGH. I believe they want us to start with the one that occurs first in the alphabet, but my point is in order means as long as you keep them in order. You can't go polygon H, K, M, J, L, G, like that. Like we go around, depending on the point that you pick first. It probably should be the one that's first in the alphabet, but you know what I'm saying. All right. Here are some examples and non-examples of polygons. Maybe you can give me reasonings why the examples are examples and the non-examples are non-examples, and we'll discuss that maybe in class the next time I see y'all. Okay, so we have convex and concave polygons. Convex polygons are ones that no points of the lines are in the interior. So you see here, like there's a triangle there in green, and I extended some lines along it, and none of those lines end up inside the triangle. Whereas on this four-sided figure, this quadrilateral, you can see some lines do end up inside. As I extend out, they end up inside the figure, and thus would be concave. Okay, so here we have different polygonal names. A three-sided polygon is a triangle. Four-sided is a quadrilateral. Yes, there are names like squares and rectangles, stuff like that. But right now, general is quadrilateral. Five-sided is pentagon. Six-sided is hexagon. Seven, hepta. You can read those. Now, after 12, anything above 12 we're going to say is an n-gon. So, for example, a 15-sided figure would be just a 15-gon. A 20-sided figure would be a 20-gon. So, kind of like that. But kind of you should know these names. Alright, equilateral polygons are polygons which all sides are congruent. Equiangular, all angles are congruent. Doesn't have to necessarily be equiangular and equilateral. If they are both equilateral and equiangular, we call them regular polygons. Irregular polygons are not regular. That is literally what the book said. It was like, duh. I can't believe you just gave me that as a definition. I was like, wow, did that take you forever to come up with that one? Anyways. Okay, so here we have a six-sided figure. So let's name it by its sides. If I look at that, based on the sides, I would call this a hexagon. I don't care whether or not it's got congruent sides, congruent angles, or anything like that. Just the fact that there are 6 sides, it's a hexagon. Now, because all the sides are congruent, but not all the angles, because these two angles right here are congruent, and these two are congruent to themselves, these two right here, but not to the other ones. Okay, so this is this is an irregular. I'm sorry. This is an irregular one that is equilateral. Also, take notice that since the sides kind of here extend into the figure, the polygon, this would be a concave. And then, we're saying this is irregular. Now, since it is irregular, I would like you to make note, is it equilateral and equiangular or neither? This one is equilateral because all the sides are the same. I can tell by all the little hash marks right there that say those sides are congruent. Okay, even if I didn't draw it that well, that's what they are. Let's look at another one. Okay, here's another one. This is an 80-sided figure. I didn't draw it as well as I could have, but there you go. But notice that I'm making these marks. All these little hash marks mean all the sides are the same, and all these little curves mean all the angles are the same. So this is, first off, if you count the sides, there are 8 sides, so this is an octagon. It is convex because no points, if you extend those lines out, none of them would end up inside the octagon, and it is regular. And that's all I got to put. Once you say it's regular, that's it, because then you know for sure it is equilateral and equiangular. Okie dokie. All right, so make sure you know your perimeter formulas for a triangle, square, rectangle, and circle, circumference, and area formulas. And don't forget that the perimeter is just the sum of the length of the sides of a polygon. The circumference is the distance around a circle, which is kind of like perimeter of a circle. And the area is the number of units needed to cover a surface. But there are those formulas. You make sure you know how to use them. And we are done for today. Thank you so much for your time. I will add one for 1.7 soon, but right now you have this. Thank you so much for your time. Y'all take care.